So today, we're stepping into the kitchen of data science. We're going to pull back the curtain on probably the most important but often invisible step in creating powerful AI. It's the prep work, what data scientists call pre-processing. So, grab your apron, because we're about to get started. And you might be shocked to hear just how much time this all takes. I mean, seriously, believe it or not, data scientists can spend over half their time, 50%, just on this one single task. It's not about the fancy cooking at the end. It's all about getting those ingredients ready to go. There's this old saying that just perfectly explains why this prep work is so vital. Garbage in, garbage out. It's the #1 rule in any kitchen, right? But it is doubly true in data science. If you start with messy, low-quality data, I'm telling you, no fancy algorithm in the world is going to save your final model. You'll just end up with, well, a useless result. So what does this garbage actually look like when we're talking about data? Well, raw data is almost never ready to use right out of the box. It can be incomplete, with missing values all over the place. It's often really noisy, full of errors, or just strange outliers. It can be inconsistent, with different records basically contradicting each other. It's just a mess, and it absolutely has to be sorted out first. Okay, so let's get our hands dirty. Our very first stage of prep work is what the pros call data cleaning. This is where we start turning that messy pile of raw information into something we can actually build with. At its heart, data cleaning is really just about tidying up our raw ingredients. The goal is pretty simple. We have to handle those missing pieces of information and filter out all the noise, stuff like errors and outliers, to make sure our data is high quality before we even think about taking the next step. One of the most common problems you're going to run into is just finding gaps in your data. It's kind of like reaching for an egg for your recipe and finding out the carton's empty. So what are your options when an ingredient is just missing? Well, you've got a few options, and each one has its own pros and cons. The simplest is just deletion. You just toss out any record that has missing data. A quick fix is something called dummy substitution, where you just fill that gap with a placeholder like unknown. Or you can get a little more clever. Mean substitution uses the average value from that column, while frequent substitution uses the most common one. And for a really advanced fix, you can even use regression, which basically uses all the other data to predict what that missing value probably was. Pretty cool, right? Okay, so we've handled the missing stuff, but what about the weird stuff? Let's talk about outliers. These are data points that are just dramatically different from everything else. Kind of like finding one super hot pepper in a whole bowl of sweet bell peppers. What do you do with that? The really fascinating thing about outliers is they can be your best friend or your worst enemy. It totally depends on what you're trying to do. For example, in fraud detection, a single weird transaction is a treasure. It's the exact clue you're hunting for. But in something like salary prediction, one massive executive salary can completely throw off the average for everyone else, making it a huge problem that just ruins your final result. All right, our ingredients are clean. That's a huge step. Now it's time for the next one, deciding which of these ingredients to actually use. In data science, these ingredients are called features, and we have to choose the ones that are going to have the biggest impact on our final dish. So what exactly is a feature? Just think of it as an individual measurable property, a single ingredient in our recipe. So for something like facial recognition, the features are the things the algorithm actually measures, like, say, the shape of the nose, the width of the mouth, the distance between the eyes. They are the absolute core components of your data recipe. Now, when you're dealing with features, there are two main philosophies. First, there's feature selection. This is like looking at your entire spice rack and picking only the most flavorful, most important spices for your dish. You're keeping the original ingredients, just fewer of them. And then there's feature reduction. This is more like simmering a bunch of spices together to create one brand new, super powerful sauce. You're actually transforming the originals into something totally new. Let's dive into feature selection first. The whole goal here is to choose the most useful, most informative features from our dataset and just get rid of the rest. It's all about making the recipe simpler without losing any of that delicious flavor. So how do we even know which features are the best ones? Well, we can use statistical tests. This table shows a pretty common one, the chi-squared test, on a dataset that tries to predict if you'll play tennis. The test gives each feature a score. And look at this, wind gets a much higher score than outlook. That tells us that knowing if it's windy is a way better predictor for playing tennis than knowing if it's sunny. There are also some really advanced methods, like something called lasso. This technique is honestly fascinating because it automatically picks the best features while it's building the model. You can think of it like a smart chef that's tasting the dish as it cooks and automatically removes any spice that isn't adding enough flavor. I mean, literally takes its impact down to zero in the recipe. Okay, so let's switch gears and move to that second philosophy, feature reduction. Remember, this isn't about picking ingredients. It's about creating new, more powerful ones. We're going from picking spices to actually making our own flavor concentrates. And the most popular way to do this is a method called principal component analysis, or PCA. Now look, the math behind it can get a little heavy, but the core idea is actually beautifully simple and it's incredibly powerful. So to get it, just imagine our data has only two features, the price of a house and its square footage. Now, they're obviously related, right? But in the data, they're treated as two totally separate dimensions of information. Here is what PCA does. It looks at all that data and finds a new single direction that captures most of the combined information, what statisticians call variance, from those original two features. It essentially smooshes them together to create a new super feature. In this case, maybe we could call it a house value score. So we've gone from two ingredients down to one, making our recipe way simpler, but keeping all the original flavor. And just like that, our mise en place, that's the chef's term for having all your ingredients prepped and ready in their own little bowls, is finally complete. I mean, think about the journey we just went on. We started with this noisy, incomplete, just messy pile of raw data. And now we have a perfectly prepped set of ingredients. They're clean, the best ones have been selected or transformed into something new, and they are potent and ready for the main event, the machine learning model. So here's the crucial takeaway. Data preprocessing is the true unsung hero of machine learning. It is the meticulous, totally invisible prep work that makes everything else, all the accurate predictions, the incredible insights, the AI you interact with every single day, even possible. It's truly the foundation that everything else is built on.